Welcome to Bite-Size Data Science. In the last video, we talked about ensembles. We continue on this subject, this time comparing their performance on two datasets. The first dataset is a variation on the Titanic dataset used to predict if a passenger survives or not. It includes 8 attributes, where one of them is a target value and another is the name of the passenger. This means that 6 attributes are available to create the model. The second dataset is a study on breast cancer detection. It includes 32 columns, with one of them being a target value and another being an ID. We then have 30 attributes for model creation. You can find links to the datasets in the description. The breast cancer data came without a header, so I added it before using the data. You can also find the attribute names used to recreate the header in the description of this video. Both datasets are used for binary classification. I am using the IBM Watson Studio environment to compare the algorithms. If you are interested, you can find a link in the description on how to create a free account on that platform. Normally, I'd use a notebook to go through the creation and evaluation of a model. This time, to make my life easier, I am using a tool that is part of IBM Watson Studio cloud environment, AutoAI. As part of the setup, I also had to add a free Watson machine learning service since it is required for the use of AutoAI. I've already created the AutoAI experiment, but I want to show you how easy it was to do. I start with adding an AutoAI experiment. I give it a name and create it. The first step is to select the training data. I pick Select from Project and then select the Titanic data. Once the data is analyzed, I identify the target attribute. In our case, it is the column Survived. We see that right away, AutoAI figured out it is a binary classification problem. Since I'm using AutoAI to compare specific algorithms, I need to modify the settings. First, I remove the name column from the training data since it won't add any value to the modeling. Then, I go to the Prediction tab and select only the 4 algorithms I want to test. Finally, I change the default number of algorithms to try to 4. This way, all the algorithms I want to test are being used. After saving the settings, I'm ready to run the experiment. This would take a few minutes, so instead, I'll go to the result of this run. We use 6 attributes to create a model over the Titanic data. For each algorithm, AutoAI creates models 4 different ways of using hyperparameters tuning and feature engineering. The result is 16 model pipelines. We can quickly compare the 16 pipelines by looking at the following graphical comparison. We see all the important metrics from accuracy to precision and recall. We can also look at the details for each pipeline. In the details of the top pipeline, a random forest classifier, we can look at different aspects of the model. Let's take a look at 2 of them. The first one is feature transformation. When creating a model, we may have to create new attributes to improve our modeling. In our case here, we see PCA and logarithmic transformations. The new features are listed in order of importance. We can go to the Feature Importance tab to see which are the attributes that had the largest impact on the decision. From the original features, we see that sex and P-class have the most impact. The breast cancer study is also a binary classification problem. One obvious difference is that we have 30 attributes contributing to the model creation. In the results, we now have a gradient boosting classifier as the top performer. Looking at the details of the pipeline, we see the following feature transformations. Most of the transformations use products and square root of attributes. Looking at the feature importance, we see that all the important attributes are from feature engineering. One more thing. AutoAI allows us to save the model as a notebook. One great way to use this capability is as a learning tool. we can see how the transformations were done and how the pipeline was assembled. There are a lot of subtleties that go into model creation and dataset impacts which algorithm performs best. Having tools to assist us to do this can save a significant amount of time and effort. See you next time on Bite-Sized Data Science, and don't forget to subscribe.